We are going to talk about the best model to fit a data set. What we see below on the first page of the notes are different types of models that are programmed into our calculator, and if our data will best fit this model, this is the one that we should use. So for instance, our linear functions are going to be data sets that are in the shape of a line. Quadratic would be in the shape of a parabola, either upward facing or downward facing. And then we have exponential with that rapid either growth or decay, kind of petering out. Those would be an exponential curve if we see a constant multiplier. We also have different graphs, some other polynomials, such as a cubic graph, where we see different, usually two turning points. Occasionally with a cubic, you might also see something like the point of inflection kind of happening. That would be best represented with a cubic. Our quartics have three turning points, and again are either upward facing or downward facing. And then sometimes you'll even get some trigonometric ones like a sine graph where we see that pattern kind of going up, down, back to the beginning on that. A lot of times what we're looking for with this is, again, either a constant growth, like addition or subtraction to be a line, or a multiplicative change like multiplying or dividing by a value. That would be good with an exponential. Or we are looking at different turning points. For instance, one amount of turning points would be best with our parabolic quadratics. But if we see two or three or more, then maybe either the cubics or the quartics would be our best bet there. Now, we have to be aware that there is always limits to what data sets we are given. So just because we're seeing a piece that might look like, for instance, a quadratic, maybe the data turns again and one of these is best suited. So we're always just going off of the data given at hand. If we look at the second page, then we are given two different tables of data and we want to figure out what our best bet would be. So if we look at the first table, we see that as our x values are increasing here, we are going from 37 to 42, 54, 66, 73, and then we notice we dip back down right here at what we would call our turning point, kind of decreasing then down to 62, down to 55, so that we see this graph has kind of that parabolic shape to it if we were kind of looking at that data. So this would best be described as a graph of a quadratic. And the reason we would say that is because it's got one turning point, and we would say that this is a decreasing graph because of that downward facing shape of our parabola. So we would say it's downward or decreasing end behavior as we finish this out. Our other graph, as we look at this, we have some more data points. This time we are starting off with an increase. We're going from 138 to 228, 288, 329, 354, 364, 67, and then right here we see a turning point where we go down to 366, 364, but then back up right here from 364 to 367, and then we keep increasing, it looks like, at the end there. So this time our graph appears to have two turning points. So this would be best represented with a cubic graph. And again, why would we say that? Well, there are two turning points that we're observing. And as we look at the end of this graph, it's increasing at the end, going up and appearing to be getting bigger as the graph, as those x values continue onward. Now, once we make the use of what kind of graph we have going, we also can use our calculators to help us then create different regressions that are going to create different functions to best fit these data sets. So for example, if we look here at the first example given, this appears to be in a linear fashion, right? This is looking kind of like a line that's increasing. So we would use a linear regression to best fit this data. So to do that, what we would do is we would take the data points that they are giving us, go under the stat menu, calculate list 1, list 2, and then go back under the stat menu to calculate, in this case, option 4, a linear regression. That allows us to get the equation of the line using those coefficient points from the calculator. And then that line allows us to do things like predict other values. Like, for instance, if they then want to predict the value of x equals 12, we could plug that into the equation and get that output value. In the next example, on the third page, we see that we have data in a parabolic looking shape. So this would best be representing a quadratic. So we would use a quadratic regression. So that, if you look under this list here, would be option 5. And again, we would type in that data, create the quadratic regression, and again, we could get a line of best fit for that data. So in example 5 here, we have a piece of data. This time we are given a new budgeting app that was launched 3 years ago. The data below shows quarterly sales, including tax. The data appears roughly to follow a cubic model, and we want to decide on the regression in this to best fit this line, again, round to 3 decimal places. Now, to double check with this, that this in fact fits a cubic, again, if we take a look at the data, we see that this is increasing from 131, 218, 279, 327, 356, 376, 385. And then on this one, notice we kind of go 390, 390, 390, and then up again. So while this one doesn't have a turning point, this is going to best, again, be a cubic, and it looks like a cubic with what we call an inflection point, because this data is kind of petering out a little bit, but it's still increasing. It's not a line, but it's got this inflection point right here where it's kind of again, flattening out a little bit before it keeps growing. That's another sign of our cubic graph. And then to actually calculate, again, this data, we are going to then type in the x values from the chart. So it looks like it goes all the way from 1 to 12. So we just keep typing in, enter each time. And then we are also going to then carefully type in the second list, our other values in the table. So we again carefully are going to type these in to the stat menu that we have here. Once we get all of that data typed in, we are going to go under the stat menu, calculate. This time we are going to calculate our cubic regression, since this is a cubic shaped graph, and we get our coefficients for A, B, and C, as well as our value of D this time, and we end up with this equation. This time, again, we're using those values from the chart. We'd have y equals the A value of 0.496 x cubed, and then minus 13.485 x squared plus 121.923 x plus 23.064. And again, rounding to the nearest thousandth, because that's what the instructions gave us on that. And we see, again, just coming from the calculator there. Now, our last piece then is they want us to use this then to calculate what we predict in year 18 that this is going to be. So we can plug in for x our value of 18 to see what that estimated output value will be. So we bring that to the third. We subtract then 0.485 x squared, and then plus 121.923 times 18. And then last but not least, plus 23.064. And we get that estimated value about 741.21 would be what our estimate then is for that last part. So again, we have the estimated, and then at year 18, what our estimated value would be in dollars. All right, thanks everyone for watching. We will work more with our regressions in class.